This is an AS FP1 question on inequalities. Use algebra to find the values of x for which x over x squared minus 2x minus 3 is less than or equal to 1 over x plus 3. Now there are a couple of ways we can do this. I could, at this point here, move both terms to the same side. So I've got something less than or equal to 0. Then make the denominators the same with those two fractions and put them together. Or I can use the method where I multiply both sides by both denominators squared. That's the method I'm going to use. Right, so let's start with the left hand side. X squared minus 2x minus 3 and times it by both denominators squared. So x squared minus 2x minus 3 squared. And then the other denominator squared, x plus 3 all squared. Less than or equal to 1 over x plus 3 times by both denominators squared. Now the point of doing this is to ensure that we're multiplying both sides by positive numbers, and that ensures that we don't need to worry about flipping the sign. Right, we can do some cancelling out now. So this denominator is going to cancel out with the square, and the same on the other side, the denominator is going to cancel out with the square. So let's now write down what's left. So we've got x times by x squared minus 2x minus 3 times by x plus 3 all squared is less than or equal to x squared minus 2x minus 3 all squared times by x plus 3. I'm going to bring everything to one side because I want to factorize it. So I'm going to have x squared minus 2x minus 3, and then the x plus 3 all squared, and then bring everything from the other side over. So minus x squared minus 2x minus 3 all squared times by x plus 3. Now it's all less than or equal to 0. I want to factorize it. That's why I brought everything to the same side. So I'm looking for factors that I can take out. So both sets of terms have x squared minus 2x minus 3. So that's going to be taken out as a factor. I'm just going to highlight the power because I do need to remember the power and make sure that's dealt with when I factorize. And then both sets of terms have an x plus 3. And again, I'm just going to highlight the power because I want to make sure I don't forget about that when I factorize. So we're taking out x squared minus 2x minus 3 and x plus 3 as factors from both terms. Now, when I do that, I will need to multiply by x and x plus 3 to get the first term, and then minus, then I need to multiply by x squared minus 2x minus 3 to get the squared, and that will be it. So I'm just going to double check. So if I multiply these by x, I get that, and the x plus 3, I get the x plus 3 squared minus, and then I only need to multiply by the x squared minus 2x minus 3. Okay. Next step is to simplify what we have in the brackets, or the second bracket, so x squared minus 2x minus 3, and then x plus 3. Now with the brackets, what can be done? So we're going to have x squared plus 3x, then minus x squared plus 2x, and then plus 3, all less than or equal to 0. Now I want to get to a point where I can factorize any quadratics or anything like that. So at this point here, I'm going to factorize x squared minus 2x minus 3. Now that is going to be x at the beginning of both brackets, and I want to get minus 3 and minus 2, so minus 3 and plus 1. So I'm now going to factorize and then simplify what I've got in the bracket here. So now I have x minus 3, minus 3, x plus 1, that's from the quadratic, then the x plus 3, which was there before. Now what happens in the bracket here? So we've got an x squared minus x squared, that's gone. So that just leaves 5x plus 3. So we'll put that 5x plus 3, all less than or equal to 0. Now from this we're going to work out what the critical values are. and we're going to use this to draw a sketch of this quartic because we're going to get power 4, and I can use these to help me work out how to draw my sketch. So I've got critical values of 3, -1, -3, and from here this is going to be let's do it down here, 5x plus 3 is equal to 0, 5x equal to -3, which gives me x is equal to -3/5. So that gives my other critical value -3/5. So let's now draw a sketch of what this quartic looks like. Now it's going to be like a U-shaped quartic because the coefficient of x to the power 4 is positive. And remember, a U-shaped quartics are a bit like cubics, but when they go down, they do some funny stuff in the middle, and then they go back up again. So let's now plot these values on this x-axis. So we've got -3, then we've got -1. This does not need to be to scale, and then -3/5, and then on the other side we have got 3. Now we just join the dots. So we start with our quartic up here, goes down below the axis, then above, then down, and then back up through the 3. Now we're interested in the part of the graph where it's all less than or equal to 0. Now that's going to be down here. Now we need to be careful because some of these values are not going to be allowed because we can't have the denominators equal to 0. So although maybe it's between these two values of -3/5 and 3, it can't be equal to -3, because if I have -3 down here, I'm going to get 0. So I'm just going to put a circle here, open circle, to say don't include that in your solution. Also, if I have -1 in my denominator down here, because that's the denominator factorized, that is going to cause a problem, so we don't want that either. -3/5 is fine, but the other value we don't want is going to be -3. Oh, sorry, this -3 is with this x plus 3 here, and this is going to go with this denominator. Okay, so sorry about that, I got it mixed up, but the idea is we don't want these included in our solutions. And when we write our solution, we want to do it in set notation. So if I was to draw it as a sort of number line, I'm basically saying, right, between these two, I want those two, that's fine, but not including those n values. Then I can include this n value here, but not this one. So let's write that in set notation. There are various ways of doing it. So I'm going to attempt to draw some curly brackets, always fail at doing that, and start by saying, right, x is going to be in a set of real numbers. However, I only want x to be between -3 and -1, but not including those. So I'll have -3 and -1 like this. Okay, so that's half of my solution, and it's that, and it's the union, because it's also this one as well, and it's not an overlap of the two, it's one and the other. And again, I'll start by attempting to do some curly brackets and saying, right, x is going to be in a set of real numbers. However, I want my x to be between 3 and -3/5, but I wanted to include the -3/5, but not the 3. So -3/5 less than or equal to, that's fine, x, and then less than, but not including the 3. So it's important that you get that, and you exclude any values that are going to give us -0 in the denominator. So that would be the solution to this question here. As I said, there are other ways in which you can give your answer in set notation.